Everybody. Today we are going to talk about the special trigonometric limits. Here we have the first one. If limit sine x over x when x approaches to 0, then we can find the limit, which is 1, and limit 1 minus cosine x over x when x approaches 0 equals 0. Try to prove that limit tan x over x when x tends to 0 equals 1 as well. Here we have a simple example. Find limit sine x over x times limit 1 over cosine x when x tends to 0. Here sine x over x from the previous rule equals 1. Limit sine x over x when x tends to 0 equals 1. And limit 1 over cosine x, we can use the direct substitution here where x equals 0. So we have 1 over cosine 0, which is 1. So the final answer is 1. We have some trigonometric limits here, and they are very useful in the following examples. If you have limit x over sine x when x tends to 0, then the result is 1. Limit sine kx over mx when x approaches 0 equals k over m. Limit mx over sine kx when x tends to 0 equals m over k. Limit sine x squared over x squared when x tends to 0 equals 1. Limit sine x minus 1 over x minus 1 where x tends to 1 or x approaches 1 equals 1. And the final one, limit tan x over x when x approaches 0 equals 1. You can use these rules in the following examples. Find the limit of the following. Limit sine 3x over sine 4x when x tends to 0. Here we have 3 over 4, coefficient of x above over coefficient of x below. So the final answer is 3 over 4. Another example, here we have the limit x minus x cosine x over sine x cosine x when x tends to 0. Now you can note that here x is a common factor, so you can take x is a common factor from above, and we have sine x cosine x here. After that you can divide this problem into two parts, x over sine x and 1 minus cosine x over cosine x. Here the limit x, the limit when x approaches 0. Limit x over sine x, we know that from the previous rules it is 1. And 1 minus cosine x over cosine x, you can use the direct substitution here. You can substitute x equals 0 here in this part. So 1 minus cosine 0 over cosine 0 equals 0. So the final answer is 0. Another example, find the limit sine squared 3x over 25x squared when x approaches 0. Sine squared 3x, it means the sine 3x all squared over 25x squared. So we can write, or we can rewrite this problem again as limit sine 3x over 5x all squared when x approaches 0. So the final answer is 3 over 5, the coefficient above over the coefficient below, to the power 2, which is 3 over 5 power 2. Another example here. To find the limit sine 3x squared plus sine squared 3x over 9x squared when x approaches 0, we have to divide by x squared. Each term here in this problem must be divided by x squared. So we have limit sine 3x squared over x squared plus sine squared 3x over x squared over 9x squared over x squared. We divided by x squared to get the form of the rule, sine x over x, sine 3x over x, and so on. So here we have sine 3x squared over x squared, coefficient of x above over coefficient of x below here is 3 over 1. So this limit will be 3 over 1. And this one, 3 over 1 squared. And here we have 9x squared over x squared which is 9. So the final answer here is 3, plus here 3 over 1 is 3 squared, and these x squared have been cancelled, so we have 9 here, and you can find the final answer. Now it is 12 over 9. The sandwich theorem, or the squeeze theorem, if you have a function f of x and this function lies between two other functions, g of x and h of x. So if you wanted to find limit of the function f of x, you have to check that limit g of x when x approaches to some number a equals limit h of x when x approaches to the same number. If the two limits are equal, so limit of the interior function here equals the same number L. So if the right limit and the left limit are equal L, so limit of the interior function equals L as well. For example, if f of x lies between 1 minus x squared over 4 and 1 plus x squared over 2, you have to find limit f of x when x approaches 0. So you have to find limit of the left hand side 1 minus x squared over 4 when x approaches 0. You can use the direct substitution and you will find the answer is 1. And the second step, find limit of the right hand side 1 plus x squared over 2 when x approaches 0. If you use the direct substitution, so the final answer is 1. Here we have the right limit and the left limit are equal. They are equal. Right limit and left limit are equal. Equals 1. So limit of f of x, the function in between, equals 1 as well. Find limit x squared sine 1 over x when x approaches to 0. To solve this problem, you have to know that sine 1 over x, the sine function, lies from negative 1 to 1. The minimum value for sine 1 over x, the minimum value for the sine function is negative 1, and the maximum value is 1. But we wanted to find limit of x squared times sine 1 over x. Here we have sine 1 over x. So you have to multiply by x squared. Multiply by x squared, each term by x squared. So we have negative x squared smaller than or equal x squared sine 1 over x smaller than or equal x squared. Use this inequality and use the sandwich theorem to find the limit of x squared sine 1 over x. Find the limit of the left hand side, the left limit negative x squared when x approaches to 0. Use the direct substitution and you will find the answer is 0. Now the right hand side limit here, limit of x squared when x approaches to 0, from the direct substitution the result equals 0 as well. So the left limit and right limit are equals 0. So the middle function here, limit x squared sine 1 over x equals 0 as well, because the right limit and the left limit equals 0. So limit of x squared sine 1 over x in between these two functions equals 0 as well. Find the limit sine x over x when x approaches infinity. If you use the direct substitution here, you will get sine infinity over infinity. It doesn't make any sense. So you have to use the sandwich theorem. You know that sine x, its minimum value is negative 1 and its maximum value is 1. But we know here we wanted to find sine x over x. So you have to divide each term by x. After division by x here, now use the sandwich theorem. Find the left limit and the right limit. Limit of the left hand side, limit of the right hand side when x approaches infinity. When x approaches infinity here, negative 1 over x when x approaches infinity equals 0. And here, limit 1 over x when x approaches infinity equals 0. So the left limit and the right limit are equal. Each of them equals 0. So limit of sine x over x when x approaches 0 equals 0. And now with the new topic, one-sided limit. To find limit of a function, for example, when x approaches 3, so here you have to find limit from the positive side and limit from the negative side, from the right and from the left. If they are equal, so the limit exists. And we have some examples after a few seconds. If you have limit f of x when x approaches a from the positive side equals to limit f of x when x approaches to a from the negative side, so the right limit and left limit are equal, which means that limit f of x exists and equals L. If they are not equal, if the limit f of x when x approaches a from the positive side doesn't equal limit f of x when x approaches to the negative a from the negative side, so limit f of x in general does not exist. For example, here we have f of x is a piecewise function and equals x squared plus 3 when x bigger than or equal 1, and x squared minus 1 over x minus 1 when x smaller than 1. Find limit f of x when x approaches a plus, or we can say x approaches to a from the positive side. From the positive side, so which rule must be used? Sure, you have to use this rule, because here x bigger than or equal 1, so you have to use from the when x approaches 1 from the positive side, you have to use this rule. So use the direct substitution here when x equals 1, so the final result is 4. Now f of x, find its limit when x approaches 1 from the negative side. So we have limit x squared minus 1 over x minus 1 when x approaches to 1. You cannot use the direct substitution here. You have to factorize this guy into x minus 1 and x plus 1. So you will find this fraction equal x minus 1 times x plus 1 over x minus 1, which is x plus 1. Use the direct substitution now, and you will find 1 plus 1, which is 2. Find limit f of x when x approaches to a in general. Here we have the two limits. The right limit and left limit are not equal, so the limit itself in general when x approaches to 1 does not exist. Another example, find the limit of f of x. Here you have absolute x over x when x approaches to 0. We know that absolute x equals x for x bigger than or equal 0 and the negative x for x smaller than 0. Now, if you substitute here absolute x over x, so you have to divide each term here by x. So this is absolute x over x. Now to find the limit absolute x over x when x approaches to 0 from the positive side, 0 from the positive side, so you have to use this rule here, which is x over x or 1. And limit absolute x over x when x approaches to 0 from the negative side, so we have to use the second rule here, negative x over x, which is negative 1. The two limits are not equal here, so limit absolute x over x when x approaches to 0 does not exist. To find limit of a function at infinity,